This is problem 13-1. It's on page 502. Specify the class of fit, the limits of size, and the limits of clearance for the bore of a slow-moving but heavily loaded conveyor roller that must rotate freely on a stationary shaft under heavy load. The nominal diameter of the shaft is 3.5 inches. Use the basic hole system. Okay. Now, to make a selection, we need a description of the various classes of fit. So let's go back. It's how it describes slowly moving, heavily loaded. It's a conveyor roller, but it must be able to rotate freely. So if we go back in the chapter, there are actually some descriptions of the various clearance fits. However, usually if you actually use these, you will use them based on experience in a particular area. Anyway, if you look on page 492, you'll see a list of fits from RC1 through RC9 and descriptions of them. And if you read through them, reading the RC7, which is the one I selected, for example, it says it's a free running fit. And that was the closest one that I could find based on their description of must rotate freely. Reliable relative motion under wide temperature variations in applications where accuracy is not critical. So I assume that this is a conveyor where it doesn't have to be terribly precise. Now that may or may not be correct, but that's what I chose. Of course, one of the advantages is over a wide temperature range it would still work. And I guess I'm thinking of a conveyor such as one in a package handling area where the package handling area is exposed to summer temperatures and winter temperatures, not necessarily a conditioned space. So that's what I selected. Now then, when I looked in the book, I noticed that the clearances of fit that were actually available in this book, in table 13.3, were RC2, RC5, and RC8. And so RC8 was the closest to the RC7, so I had to go with that. Now I could have grabbed Machinery's Handbook and looked up an actual RC7, the one that I selected initially, but I decided just go with an RC8. Alright, now the size of the basic size we're dealing with is 3.5 inches. Now to find out the limits on that size, look in table 13.3, it is on page 492. And you'll notice that 3.5 is between the row that has nominal size range of 3.15 to 4.37. So this is between, 4.73. 4.73 and 3.15. So that's the particular row we're on. Now, we want an RC8 class of fit. So if you go over to the RC8 and look at the hole on that row, you see that the standard limits are +5 minus 0. So for the hole, or the female part, that is +5 to 0.0. So the numbers in this table are in thousandths of an inch. So the hole can be 3.5 inches exactly, or 3.5 plus 5 thousandths of an inch. On the other hand, the shaft, the limits of size on the shaft is under by 7 thousandths all the way down to under by let's do it this way, under by 10.5 thousandths. Okay, now the limits of clearance are given as well. Limits of clearance are 7 to 15.5. Now you can derive this from the information that we've got pretty easily. Notice that if the hole is 0 under, so it's exactly 3.5 inches, or 0 over, if it's exactly 3.5 inches, and the shaft is at minimum 7 under, then there would be 7 thousandths of clearance between the two parts once they're assembled. On the other hand, if the hole is large by 5 thousandths and the shaft is undersized by, it's not real clear, 10.5 thousandths, then those two are going to give you a clearance of 15.5 thousandths on the part. So if we're supposed to specify the size, then for the hole, we could specify it as 3.5050. I'm going to go all the way down to 1/10,000th to 3.5000. So there's the call out that would be on the hole to specify its size. And the shaft, well, it would be 3.5 less 7 thousandths, so that is 3.4930. Notice the 7 thousandths is, taken away from that position. And then it could be all the way down to 10.5 thousandths. So the smallest size would be 3.4895. To check my numbers, just add 10.5 thousandths here. Okay, so 10.5 thousandths would be like that. Add that, and you'll see you get 3.5. Add 7 thousandths to this, and you'll see that you get 3.5. So there are the limits of size for the hole in the shaft, which is let's see, yeah, limits of size and clearance. So we know the clearance range, and we specified a class of fit. So that's the end of the problem.